Hello everyone, I'm Steve Smith. I'm going to talk about resilience as a continuous delivery enabler. I'm going to talk about robustness, resilience, operability, and continuous delivery, and how we turn them all into a lovely big soup. I'm a continuous delivery consultant and a trainer. I'm not a big name speaker, but I am a tall name speaker. One of you here in this very room refers to me as the Shakira of continuous delivery. I don't know what that means, but I do know that I'm the person you called when Dave Farley and Jez Humble won't phone you back because they're too busy reenacting that scene from Lady and the Tramp. You know which one I mean. So I'm the author of Measuring Continuous Delivery, which is a book on making better decisions when adopting continuous delivery. It's available on LeanPub. I wrote another book, and I'm associated with Equal Experts, which is a network of software delivery experts. There's a whole bunch of them here this week, and you should talk with them. They're very nice people. All right, so what's the challenge? So the perennial challenge we have in IT is how to achieve a delivery speed fast enough to satisfy business demand and at the same time achieve sufficient reliability to protect our daily business operations. If our deployments are too slow or too unstable, then we'll be in a state of what I like to call discontinuous delivery, and nobody really wants to be there, although most of us here will be. When our IT services are unreliable, then we're vulnerable to outages, and the cost of downtime can be ruinous if market conditions are against you. Now, it's 2018, so we all came here by Hyperloop. You know, I saw a number of you in the tubes. It was good to see you. And of course, now Cornwall has contactless. Who else here is from Cornwall? Put your hand down if you were born east of Falmouth. Okay, the ones with hands still up. Yes, we can be for me and you. We can be friends. All right. So I'm from Redroof. I am proper Cornish, not from up country at all. Now, you'd think we'd have all this figured out. You know, Cornwall has contactless now. It's amazing. I didn't think that would happen in my lifetime. I've lost a lot of money now on substantial bets. You know, I was in a taxi yesterday, and the guy had a card machine. I was like, "You got a card machine?" And he was like, "I do." He said, "I've used it twice, and I don't like to use it." And then someone radioed him to say the radios aren't working. And then he said, triumphantly, he lunged for the radio and went, "Technology will always let you down." And I nodded my head so hard it nearly came off. Now, so now that we're living in the future, even here in Cornwall, you'd think we'd have this challenge kind of figured out by now, but of course we don't. It's kind of laughable, really. In fact, what happens with a lot of companies is that their reliability strategy is actually a cause of discontinuous delivery. We'll come on to that in a moment. So first of all, what's reliability? When I think of reliability, I think of Patrick O'Connor and Andre Kleiner's book, Practical Reliability Engineering, and they describe reliability as the probability that a system will perform a required function without failure for a stated period of time under stated conditions. Reliability is what keeps your organization afloat. Kids don't leave home without it. When we measure reliability, we normally use mean time between failures and mean time to repair. Reliability is often considered a function of these two things. So that's the average time between things going bang and the average time it takes you to find and fix a thing that's gone bang. Now, if John Allspore was here, he'd say that we shouldn't use mean, and he's probably right, but he's not here and I'm bigger than him. So we'll stick with MTBF and MTTR. Okay, so now we're getting on to some good stuff. So when an organization deludes itself that IT as a cost center is a viable technology strategy, invariably the reliability strategy is to optimize for robustness. That means trying to maximize the ability of IT services to resist failure, and you do that by implicitly prioritizing actions that favor a higher MTBF over a lower MTTR. So how do we do this? Nobody screamed. We do it with these practices, these old favorites. We optimize for robustness with mandatory code reviews, end-to-end testing, segregation of duties, change advisory boards, change freezers, I love change freezers, and root cause analysis. Robustness is a desirable capability of an IT service, don't get me wrong, but to optimize for robustness means spending too much time for too little risk reduction. Okay? Now, earlier on in my career, the use of these practices enraged me, and over time I've learned two anger management techniques that I'd like to share with you. Number one is to apply Curve's prime directive in everything you do, and to always assume that people are working with the best of intentions in difficult circumstances with constraints that you can't understand. And number two is to poke fun at absolutely everything until you get called into a meeting room to be told off. So if the two things together, very useful, okay? So let's look at some of these really vital and essential practices. End-to-end testing, that old chestnut. So end-to-end testing is about testing a new service version against its unowned dependent service versions. I did a whole talk in 2016 about how awful end-to-end testing is, and it is. But in short, end-to-end testing understandably looks kind of attractive because it promises a high degree of test coverage at a low rate of investment. And that's because you're testing the whole system itself with itself. But it doesn't really work. End-to-end testing is a dirty, dirty liar. You'll only ever have a low rate of test coverage at a very high rate of investment. So when have I done it? Too many times. In government, a couple of years ago, I was an operations team lead. We had about 60 teams, and some of the teams were doing end-to-end testing if I was asleep, perhaps, or working elsewhere. And why won't they stop doing it? And what we'd find was that some teams would spend between 4 to 6 weeks just preparing for their end-to-end testing, right? They had to get the right test data in place. They had to get the right spreadsheets in place, the right third-party representatives in place. And then the tests themselves were too slow and too intermittent for anyone's liking. And we did a bit of a dive into the data on the test environment. And we found out that the test instances of those third-party systems were 700 times slower than they were in production, and they could only handle 1% of production load. So they were very production-like. That was a good use of everyone's time. But I didn't mean that, by the way. If I say something about continuous delivery, I'm telling the truth. If I'm talking about something else, I'm probably not telling the truth. CABs are used to assess, prioritize, and approve the deployment of new service versions. They're normally a part of a heavyweight change management process. They add a good few days onto your lead time. And of course, we all know that extensive documentation and ceremonies can't actually prevent production failures from happening. A couple of years ago, I worked in an API team at a digital media company, and there was a really slow and frustrating CAB process. It took a couple of days to arrange. We were never quite sure who you had to have there. You had to put on the robes. The robes were very heavy, very hot. And you'd go and they'd say, "Have you sacrificed the goat?" I sacrificed the goat. And then, "Did you bring the crab?" Like, "We brought the crab for you." And then, "Do you pinky swear it's not going to go wrong?" "Oh, I suppose I'll pinky swear it's not going to go wrong." And of course, things did go wrong. One time, a change manager even triumphantly whipped out their laptop and started testing in front of us, going, "These testers don't know what they're doing." I nearly gave them a Cornish voice then, which is weird because they weren't Cornish, but they could do it anyway, I think. So, "Oh, these testers don't know anything. I'll find out. So I'll find something here. Don't you worry." And of course, they found a little tiny problem and said, "We can't have any deployments today." And that was a good use of everyone's time. That was excellent. That was a really good day out. So there's one laugh coming in there, which is a good sign that things are going exactly as I anticipate. There's no commercial future in this, but one person's getting the artistic value of this. So change freezers really are my favorite. I can't get off. There's one person here somewhere who won't put their hand up because they're too ashamed, but they're now into the second year of their change freeze. Yes, I can see them. I think that's just fantastic. 2 years, that is a commitment. A few weeks, no, we're going to freeze everything, for 2 years. And it's a startup that all of you use, it's just amazing. Good luck to them, that's what I say. Going to work well, that. So a change freeze is about deferring, preventing the deployment of new service versions because there's a perception of unfavorable market conditions. I think that's the polite definition for a change freeze. Many companies do change freezes because they see a deployment as a major source of failure, so they want to stop that happening. But of course, a change freeze trying to control change, it's a bit like trying to catch raindrops with your tongue. It looks kind of silly and it doesn't really work, but people still do it, so what the hell. Now, a couple of years ago, I was going to do a talk on change freezes and how absolutely terrible they are, but I don't need to because Baron Schwartz wrote this really great article online. I think it's called "Why Deployments Don't Prevent Outages." It's got a picture of Arnie on. There's Mr. Freeze from that Batman film we don't talk about anymore. It's a really great article. Now, this idea that you can stop change is just fantastical because obviously, scheduled tasks are firing, system clocks are ticking over, disks are filling up with logs, and of course, users are doing things. Whenever a company says to me, "We're going to have a change freeze," I always say, "Great. When are we going to turn off all the servers and tell the users to leave us alone and go to a competitor?" But so far, no company has taken me up on this new approach to change freezes. So yes, but do read that Baron Schwartz article. I sent it to everyone. I made my mother read it. I handed it out to strangers on the streets of Penryn last night. It's well worth a read. Now, a couple of years ago, I worked at a telco. This one is actually completely real and not an amalgamation of different clients. This one is actually one company, so please don't look on LinkedIn and find out who the company was. So, yes, I worked at a telco. I was team lead on a broadband team. So we had broadband teams, we had TV, we had mobile, we had the other one. And we didn't have change freezes because we knew they were wrong. We liked to have periods of heightened awareness where everyone had to be, at maximum awareness at all times. And there was one particular time where we had a meeting of the whole department, and my manager stood up and said, we're going to have a period of heightened awareness now. So it's going to happen in 2 weeks. It will last for 2 weeks. And we are going to have no deployments, no changes across the whole company, across the whole country. And Steve is not to ask questions, because I had been known to question periods of heightened awareness. And at that point, I put my hand up and said, why can I not ask questions? And I immediately got into trouble, which was excellent, remembering my second anger management technique. So then I spent 2 days of the company's time trying to find the reason for this period of heightened awareness, which I did and still do consider an excellent use of the company's time. And it was quite difficult. I'm looking for some sympathy here. There was no general election. There was no football on. There was no cricket. There was a thing in East Timor, but I didn't think it would be that. And in the end, the only thing I could think of was that there was a G8 meeting for 2 days that nobody would watch on TV in a town in Britain that nobody could spell. And I had a meeting with my manager, and I said, is it because there's a G8 meeting that we'll be televising in a town in Britain that nobody can spell? And my manager said, yes, it is, and I don't want to talk about it. And I said, why is that? And he said, why are you putting your hand up, we're alone? And I said, for a consistent narrative. And he then said, look, just leave it. And I was like, okay, no worries, boss. And then I went outside, and for 4 days I pranced around the company asking out loud how you could have a change in a broadband service that would have this fantastical chain reaction that disrupted TV coverage of a G8 meeting that nobody's going to watch in a town in Britain that nobody can spell. And it was at that point I was called into a meeting room for one of the 4 really big tellings off of my career. And I remember with a great deal of fondness, I would do it all over again. I regret absolutely nothing. So leaving aside jokes for a moment, these practices have some value. I don't think anyone would deny that. But to an extent, they're all risk management theatre. Okay? So that's the term that Jez Humble coined to refer to the sometimes well-intentioned and always misguided assumption that imposing preventative controls on everyone is going to stop anyone from making a mistake. These practices will impede knowledge sharing, they will restrict situational awareness, and they will ironically increase risk. Has anyone here read any of Don Reinertson's books? Maybe it took a second or third go. There's no shame in admitting to that. When you eventually plow your way through on all fours through one of Don's books, and you'll learn through some nice equations and reasoning that the bigger the change, the larger the batch size, the more risk there is, the likelier it is that something will go wrong, the harder it will be to unpick it afterwards. So doing these things actually makes things worse. On top of that, there's a belief in optimizing for robustness, that a production environment is always failure-free, and that often leads to this underinvestment in operability, and it actually leaves you ill-equipped to deal with production failures. You'll probably have inadequate telemetry, snowflake infrastructure, fragile architecture. Now, a failure occurs when multiple faults unexpectedly coalesce so that one or more business operations can't succeed. And what will happen is the defect will start, and then it takes you a while to discover it. That will be your sunk cost in the defect, and that will be worsened by inadequate telemetry because your situational awareness won't be great. You won't actually be able to discern your abnormal operating conditions. Between defect discovery and defect resolution, there's an opportunity cost to incur, and that's going to be increased by snowflake infrastructure and a fragile architecture because it will increase the failure blast radius. On top of that, there's often this attitude that Sidney Dekker refers to as the bad apple theory, that a production environment and organization itself is entirely reliable except for a few unreliable actions by a few employees. And when you combine that with hindsight bias after a failure, then you get this really oppressive naming, blaming, and shaming culture that we should all be ashamed of. So here is our fictional fruitsy-like organization that we've all been slaving away over a hot stove for. And let's say we've got a 10-week lead time to production. We've got end-to-end testing and a cab because, we optimize for robustness around here. Stop asking questions. Put your hands down. Don't have meetings with managers about it. And let's say that we depend on a third-party registration service. There always is one. No one ever writes a registration service. There's always a company you depend on, and they always let you down. And let's say that Fruitsy-like has some kind of spike in website traffic, and there's an increased rate of failure for new customers in checkout. That's a nice little example, actually, because what that means is that existing customers will continue to be able to purchase our lovely fruit, while new customers will be stuck. So your abnormality might be harder to find. And it will certainly be harder if you don't have sufficient telemetry. So let's say it takes a couple of days to find this production problem. That's certainly not too exaggerated. I've known a couple of clients that have had that kind of scenario. So let's say our failure has like a static cost per unit time of £80,000 a day. So 3 days, 80K, that's nearly $250,000. That's a sunk cost, you'll never get that back. Let's say then that our checkout team have a connection handling fix put into the code. They go to cab, and the cab say, don't do end-to-end testing, we need to get this in quickly, remember that. And that goes into production, so that's 5 days. That's a lot of money lost, right? And that's just direct revenue costs. There's also indirect opportunity costs to consider as well, loss of customer confidence, reduced return from existing customers, that kind of thing. So if optimizing for robustness is so bad, and it is, and if change freezes are so horrible, and they are, why do organizations still believe in optimizing for robustness? And people do believe in this. And I think it comes back to Gerrit's keynote yesterday about people kind of craving certainty. There are some underlying assumptions here that it's good to unpick. So people tend to believe that a failure is caused by a single fault. People believe that a failure is caused by a single individual. People believe that failure should be preventable. A production environment is thought of as a set of homogeneous processes with predictable interactions occurring in repeatable conditions. And that actually matches the definition of a complicated system in which an expert can accurately predict the cause and effect of events. We put in apples, we get out an apple pie. We put in apples, we get out an apple pie. Unfortunately, the world isn't like that. The world is messy. The world is stochastic. The bad news is a production environment of running IT services is not a complicated system, and to think so is unfortunate. A production environment is an intractable mass of heterogeneous processes with unpredictable interactions in unrepeatable conditions. You put in apples, you get out an elephant. You put in apples, you get out an orange. Oh, that was close. You put in apples, you get out a lion. Oh, that was further away. Right, you can't predict what's going to happen. Okay? It's a complex system of dynamic elements, emergent behaviors. The cause and effect can only be perceived in retrospect. Richard Cook wrote a really great paper on this a couple of years ago called How Complex Systems Fail. It's only a couple of pages. You should totally read it. And he said in it, the complexity of these systems makes it impossible for them to run without multiple flaws being present. Your production environment is always in possession of faults. It is always in the state of near failure. Catastrophe is always close by. Okay? Sorry. So what was interesting in our carefully contrived Fruits You Like example was we had this whole 5-day thing, right, where we go to cab and we're told we don't need to do our end-to-end testing. And what happens in pretty much every organization I've ever worked for or with is that each technology value stream will actually have 2 value streams itself. And this is something I call dual value streams. I think I first talked about it here a couple of years ago when we were over on the other site. What happens is that every organization, let's say, every organization that optimizes for robustness, there will be a feature value stream with all of the advertised risk management practices, okay? It will have end-to-end testing, it will have cabs, it will have change freezes, it will have mandatory code reviews. And then when there's a failure in production, something different happens. People understand that a sunk cost has been incurred. People understand that there's an opportunity cost that needs to be minimized. People will appreciate the cost of delay. And then we'll have a truncated value stream where we sacrifice those risk management theater practices for speed. Okay? Now, I'm really interested in this because as a continuous delivery consultant, I like to think that this fixed value stream, it shows you the potential for throughput improvements. If you can actually get something into production in 5 days, if you can find a problem and resolve it in 5 days, why can't you do that with features? And there's a really interesting implication here that if a practice is in your feature value stream, but it's sacrificed for your fixed value stream, it's risk management theater. And there is some truth in that, but in the wild, it's not quite as easy as just going, right, well, let's yank out all of these things that we don't do for production fixes, and then we're doing continuous delivery. Hooray. I have a friend who's actually not here, that they were brought into an organization a couple of years ago to help a team move from monthly to fortnightly deployments. and they very quickly identified end-to-end testing as the constraint on lead time, and they expended all of their political capital, all of their energy, all of their time on the removal of said end-to-end testing. And they got the team down to fortnightly deployments. The first fortnightly deployment failed, and the knives came out. So my friend got in a lot of trouble. The team was told monthly deployments is where you're going to be pretty much forever. And my friend ended up leaving the company, which was a real shame. A continuous delivery program that's focused on throughput alone is always vulnerable to cancellation. Okay? It's not as simple as strolling into an organization, yanking out those practices that you deem to be risk management theater, and then kicking back and relaxing. Okay? We need to do something a little bit different because these practices are part of the organizational fabric. When your continuous delivery program has its first production failure, and it will, because it's a question of when things fail, not if, when that failure happens, skeptics will lobby for a return to the status quo, and it only takes one inopportune failure for things to be rolled back. Okay, that's something I've experienced myself as well. So, if optimizing for robustness is really bad, which it is, and if a continuous delivery program focused on throughput alone is insufficient, which it is, what should we do instead? Well, if an organization wants to change its technology strategy from IT as a cost center to IT as a business differentiator, if it wants to move from discontinuous delivery to continuous delivery, then there needs to be a change in the reliability strategy. We need to optimize for resilience instead. And that means maximizing the ability of services to rapidly respond to failure. And it means explicitly prioritizing actions that favor a lower MTTR over a higher MTBF. Okay? A low MTTR will minimize the cost per unit time and the duration of failures. We need to build a production environment that can cope with unexpected behaviors, sudden surges in demand, and surprise events. Again, robustness is desirable. There are some classes of failure that simply should never happen. Some failures are more costly than others, and some systems should, never fail. The ship we're going on tonight should never fail. But in general, being able to recover faster from failure is more important and more valuable than trying to prevent failure, and you are more likely to succeed. So, resilience can be thought of as graceful extensibility. There's a lot of really good literature out on resilience engineering. Normally just follow John Allspaw on Twitter for a summary of it all. David Woods has described resilience as graceful extensibility, and he's talked about it as the capacity to extend and adapt when surprise events challenge your boundaries. Graceful extensibility is derived from the adaptive capacity of the hardware, software, and people in a system. That's the available capacity for adaptation when a failure is nearby. Interestingly, graceful extensibility trades off with robust optimality. Okay, this is a really subtle but important thing. Okay, when you create sources of adaptive capacity, when you start to grow a more resilient system, it will appear as if you are creating cost inefficiencies. Okay, and there will be a temptation to eliminate those cost inefficiencies, but then you are moving back towards robustness. Okay, because you are removing your ability to respond to unknowable future events. It's sometimes known as like the audacity of resilience to actually keep that reserve capacity in place. Graceful extensibility is also the foundation of sustained adaptability. An organization that's able to respond rapidly to production failures can learn in time to become more responsive to turbulent market conditions and innovate in the face of disruption. That gives you a really powerful first mover advantage over your competitors if you can quickly respond to changes in a market. So, how do we create this precious adaptive capacity? A really good way to do this is to invest in operability. So a friend of mine, Dan Mitchell, is here. He's a bit of an operability guru, and we spent a lot of time together last year talking about the relationship between MTTR, operability, and continuous delivery. Operability is all about making it easier for people to keep running services in a reliable and safe functioning condition. And operability is often associated with these kind of practices: adaptive architecture, feature toggles, automated provisioning, chaos engineering, pervasive telemetry, runbooks. You build it, you run it. Chris O'Dell gave a great talk on that earlier today. And post-incident reviews. Each of these practices will increase the adaptive capacity of your services in production, and they will lead to a more effective incident response. All right, so we know that optimizing for robustness is bad, we know that optimizing for resilience is good, and we know that operability can get us to optimizing for resilience. But how does this tie in with continuous delivery and giving ourselves a better chance of success with continuous delivery? There's no recipe for success with continuous delivery. Don't read maturity models. Don't listen to people who rock up and say, do these couple of things and it'll be fine. Don't listen to someone who goes, put in this new tool and it'll be amazing. But we do have heuristics, okay? And I can tell you that a continuous delivery program needs to be bootstrapped. It needs a set of formative changes that can kickstart it. You want to rectify immediate problems. You want to embed essential practices and kind of set the tone for your overall program of work. If we use optimize for resilience as a prioritization heuristic, then we can learn to adopt continuous delivery in such a way that we're favoring a lower MTTR at all times. And we might have some bootstrap actions that look similar to this. We can start out by improving stability with version controlling absolutely everything. Then we want to measure stability to improve our awareness of our journey. Then we can improve reliability with production telemetry and an adaptive architecture. And then after that, we can start to run our parallel experiments, try out all of our continuous delivery and operability practices in that enormous soup of stuff that we have to do. This approach demonstrates a commitment to transparency and to reliability that will build confidence, help to win over skeptics, and lay the groundwork for challenging risk management theatre later on. Okay, so don't just blaze in and say, let's get rid of the end-to-end testing. Okay, put some things in place first that will make it easier for you to persuade people of the benefits of an alternative approach. So we start off by storing all code, configuration, documents, and configuration and version control. The State of DevOps reports and Accelerate by Dr. Nicole Forsgren and her colleagues consistently show a lack of version control to be the most frequent source of failure in IT systems, and especially a lack of version control for application configuration. We can improve awareness by creating stability and throughput measures, metrics, indicators to help people better understand the delivery capabilities and help them to make better decisions. I won't talk too much about this, it's a bit self-serving. I have a real deep dive into this topic in my book, but it's pretty straightforward. You have put some measures in place to understand how fast you're going, how often things are going wrong, and then you visualize those in surface trends, patterns that help you understand where really valuable conversations are lurking. How hard can that be? Buy the book, My Children Need Shoes. Why would you want my children to suffer? Don't understand. Improving reliability minimizes the cost of failure. And production telemetry and an adaptive architecture are really, really vital. And you can implement these in parallel by all means. So telemetry is about logging, monitoring, anomaly detection, alerting, and user analytics. It's about helping people to perceive normal versus abnormal operating conditions. Automated anomaly detection can speed up the detection time of anticipated failures, which will reduce the sunk cost duration of an incident to maybe minutes instead of hours or days. Implementing telemetry early on also provides you with a bit of insurance for unsafe to fail situations. When you have a failure in production as a result of some change you're making for continuous delivery to take seed or to grow, it's pretty useful to have some telemetry in place that shows which faults contributed to the failure, which faults were introduced as a part of some changes you might be making, and which faults were lying dormant in production beforehand. Okay? A failure is never caused by a single fault. It is triggered by one or two faults at the end. There will be stuff that's already been lying around, and surfacing that information will help people understand that it's not just Steve in a corner setting fire to things. Okay? All right, so what else? Adaptive architecture. This is really, really important. I think of architecting for testability and deployability as like a force multiplier for continuous delivery. This is about making significant, hard-to-change design decisions about limiting the blast radius of a failure. Two obvious examples here of architectural patterns we might use are circuit breakers and bulkheads. With a circuit breaker, we wrap remote calls to a downstream service in some monitoring code. If too many calls to that system fail in too short a period of time, then we back off. We don't let any more requests through, or we at least regulate the rate of requests. And that way we avoid saturating a problematic dependency. Bulkheads are about returning default responses, friendly responses to users when we are experiencing some kind of failure. It's about turning a hard failure into a soft failure. It's about continuing to operate and continuing to make money in a partial state of failure. So an adaptive architecture gives you the ability to decrease the cost per unit time as well as the overall duration of a failure. And when people have the positive experience of a production failure that's partially mitigated, that can really change their perception of reliability and of the kind of changes that you want to make. And after that, that's where we go mad and we try all of our different continuous delivery and operability practices, use an improvement kata, use the plan, do, check, act cycle, do all the things you need to do to gradually move towards continuous delivery. Okay, so instant response at Fruitsy like would be vastly improved if there was telemetry in place. Let's assume that there's another spike in website traffic, but this time that naughty third-party registration service, I tried to warn them about it. Let's assume it struggles again under load, and this time there's an automated alert that goes to the checkout team, and they have a monitoring dashboard that clearly shows a correlation between new user failures on checkout and a spike in failures from that registration service. So now the checkout team can do another connection handling fix, get that into production within a day or so. If we assume the same cost per unit time, then we're down from 400K to 80K failure. You know, that's pretty good work. Now let's assume that the checkout team are really sick and tired of this rubbish registration service that they simply have to use, and they put an adaptive architecture in place. They wrap their calls down to this registration service in a circuit breaker. Let's say that if there are more than 5 registration failures within a minute, then we simply stop any more calls to that service for a period of 5 minutes and give that service a chance to respond. Let's say that there's a bulkhead put in place as well, so that the checkout front end is told that when there's a registration failure, simply let new users continue through. We'll register them next time, right? Let's let them make their purchase, let them buy our lovely fruit, which will probably arrive squashed and sore, but that's not our fault. And let's continue to let users use our website. Just because they can't register is not the end of the world. So if we do that, that's an example of how you shrink the cost per unit time of a failure, okay? That's how you turn a hard failure into a partial failure. And yeah, then it will be costing you less money. Okay, now we can start to tackle that risk management theatre. I hadn't forgotten about it. Because we have a solid foundation of changes in place that have already improved reliability, and I've already shown people that we're not just about increasing the speed of delivery, we're also about achieving sufficient reliability. Now, the key to removing risk management theatre is to visualize its cost to stakeholders and outline practical alternatives. Let people see the problems for themselves. Don't just rely on theoretical arguments. Optimizing for resilience from the outset of a continuous delivery program will ensure that those visualizations are in place. We can use our indicators, our graphs of stability and throughput to show people like the historical cost of those pre-production risk management practices. We can show people maybe that we've got a 10-week lead time to production and 5 weeks are spent in end-to-end testing. Perhaps people haven't actually seen that before. That can be a really powerful information radiator. Once we've got our adaptive architecture in place, our telemetry changes in place, then we should be able to shrink our MTTR down to minutes or hours at most. When you can respond to a production fix an order of magnitude faster than you can put a feature into production, it becomes easy to have conversations with people and to say, why is it that we can do things in 5 days, let's say, when we all share a sense of urgency, when we understand what's going on, but it takes us 10 weeks to actually put a really useful, valuable feature into production, okay? And let people see the problems for themselves. We don't actually want to eliminate risk management theatre and robustness practices. We just want to reduce it. We reduce the constraint so we can balance the flow of value-adding changes through our technology value streams. End-to-end testing should be gradually superseded with a multifaceted testing portfolio. That's going to include unit tests, acceptance tests, contract tests, smoke tests, production monitoring, pre-production monitoring with exactly the same tools, and an adaptive architecture. So back in government, reducing end-to-end testing was a long-term thing. It was over a year, I think, we were working on it, doing other things as well, of course. We obtained a lot of quantitative data on lead times and how much of those lead times were spent on end-to-end testing. We looked at the reliability of these test systems, as I mentioned, and we also took on qualitative data. We talked to teams who were only too happy to volunteer how miserable their lives were because of end-to-end testing. Some of our teams then trialed some new approaches to testing. One team beefed up their acceptance tests. One team did contract tests with a really flaky read-only third-party system they just had to use. One of those government systems where everyone's like, it's been here forever, don't touch it. Another team created this enormous monitoring dashboard with some really lovely vanity measures like how much money government's made today because of our system, which is awesome for getting conversations going about monitoring, even if it's not terribly actionable. We wrote a position paper with all of our data and some of those narratives and explained to people why end-to-end testing wasn't working for us, how we had a new approach that we'd like to trial with different teams. We had a really big emphasis on positive communications and positive intent and transparency. In the end, a couple of us went to speak with the head of testing for the whole government department, who agreed that we should stop doing so much end-to-end testing and try this approach, this new testing portfolio, with all of our 60-odd teams. That was great. It was really, really good conversation. So cabs, you don't need to get rid of cabs. Okay? You reserve cabs for big, risky deployments and then do everything in your power to avoid big, risky deployments. Smaller, less risky changes should go through a lightweight change management process, and continuous delivery is really good for that because its whole emphasis is on people working together with small changes to reduce risk. A deployment pipeline is a really, really powerful change management tool. It's an automated audit trail of who did what when. Okay? That's something that a lot of cab folks will never have experienced before, and you can just give it to them, right? You kind of have to build it anyway, right? And you should invite cab folks to your team planning meetings, invite them to retrospectives, like just have a transparent approach from the outset. And if you're in love with ITIL, then that's fine. It's entirely possible to follow ITIL with continuous delivery. The service transition standard makes available normal changes and standard changes. Standard changes can be pre-approved, electronically authorized in advance, and continuous delivery is all about having smaller changes that can be done on a regular basis. Back at our digital media organization, we realized that our cab folks couldn't actually know anything about how we actually delivered our software. So we explained to them that we had immutable release candidates. We explained our configuration was version controlled. And most importantly, we showed them our pipeline metadata. We showed them that they could observe for themselves. When a particular change was made in production, it could be traced all the way back to the original code change and who did that change, and it had their contact details as well. That was something they'd never really experienced before, and they were quite excited by that. We agreed to follow this idea, at least in name, of normal and standard changes. We said that we'd have big, risky deployments. We'd have a 4-day lead time to a cab, and smaller, more regular changes could be done on a daily basis and just approved in bulk. So guess what we did the moment we had that agreement? We changed the way we did planning, we changed the way we did development, and we changed the way we did testing to make things as small and tiny as possible. And within a month, we went to daily deployments with the backing of the change management team. Okay, that was really great. Change freezes shouldn't end. We should keep them because I love them. We should have more of them, and they should be longer. 2 years, we should just keep going. I didn't mean that. So change freezes should be eliminated, actually. I can't stand the things. But I love them too. It's a love-hate thing. But we can end them in favor of incremental launches, okay? We need to decouple the technical action of deploying software from the business action of launching features, okay? There is no reason in 2018 with our contactless in Cornwall that we need to have these two things coupled together, okay? That really is an antiquated notion, all right? Just disable new features with feature toggles, okay? Do blue-green deployments, do canary deployments if you want to trial a particular production change and then turn it off again, right? If you see any particular problems. New features can then be toggled on when market conditions are less turbulent. You can even go more towards dark launching, and then you can roll out features to a particular user demographic. Now, that's a really powerful weapon for user analytics. Your business stakeholders will love that stuff, and they will then turn out to be your biggest advocate for getting rid of change freezes. Back at our telco, we had periods of heightened awareness which we couldn't control. We could find out the reasons for them when we were told not to. But we could also control how and when we launched features. Okay? So whenever we added a new feature to an existing service, we wrapped it up in a toggle. And when a deployment happened, it was turned off. And then I think at 10 in the morning, we were crowded around a monitor, and we would turn stuff on. If it wasn't working, we would just turn it off again. If we were in a period of heightened awareness, we didn't have to ask for deployments. We asked for config changes. We said, can we just change this runtime config? And everyone was like, yeah, sure, just a bit of config. Our stakeholders, our product owner, our business analysts loved the ability to choose when things were rolled out and who it was rolled out to. They'd never had that ability before to actually decide when something happened. They could do their marketing as they wanted. They could turn stuff on for a particular town or a particular part of Britain and then see how customers responded to it. After a while, they liked that so much, they started to push back and change features. They were the one on the phone saying, I don't want this period of heightened awareness. I'm just going to turn stuff off, leave the team alone. I know what I'm doing. That was great to see. Okay? If you give the ability to choose when to launch stuff, then you can change freezes. All right, so in summary, optimizing for robustness is an antiquated, flawed approach to IT reliability. It results in long-term discontinuous delivery and an operational brittleness that can't cope with major failures. Robustness is valuable, but you should reject it as an outcome if you want to be able to innovate in changing markets. Optimizing for resilience is a superior reliability strategy. It enables an organization to gracefully extend to limit the impact of failures. So James Lewis, this conference, we've been talking a bit about paradigm shifts, and this is a big change, okay? This is a big change in mindset for people to accept that something is complex, not complicated, to accept the production environment already contains faults, to accept that failure is only just around the corner, that it's not failure-free. That is a big mental hurdle to get over, okay? But if you can help people do that, if you optimize for resilience, if you gradually introduce new practices that will lower MTTR, then that will really help people. And visualize stuff, let people see the problems for themselves, and then gradually introduce some of the changes I've recommended here to help you reduce the risk management theater in your organization, in your feature value streams, and that will help you move towards continuous delivery. So thanks very much for coming, and happy to take questions. Do we have any questions? Hello? I understand. So let me just play that back so other people might not be able to hear you. So we're talking about automated versus manual testing, where I see them fitting in the value stream. Okay, thank you. So I probably should have said, end-to-end testing is when you have a large number, I might have said it, you have a large number of manual or automated tests. Exploratory testing is really important, and test automation should be introduced in order to free testers up for exploratory testing, okay? That's a really, really important thing that a lot of testers can't do because they're drowning in manual regression testing, or someone somewhere decided that they should be the one that write the automated tests, which is not a good idea. Okay? So the way I like to see things happen is that developers write unit tests, developers write automated acceptance tests that are stubbed, testers advise the developers on how to write those acceptance tests. They help developers change their mindset a little bit and think more about surprise events, boundary conditions, unexpected situations. And after that, we have our exploratory testing, right? We have our testers with the ability not just to go and mash the keyboard and see what breaks, but to actually think about what happens if two users register at the same time. Will they both be able to check out? That kind of thing that's really hard to automate. Okay, does that answer your question? Also, we can talk more afterwards if you like. Any more? Hi there.
I'm trying to help my team work on one thing at a time.
Good.
But we really need to fix a lot of our monitoring and alerting while doing features.
Okay, so the question again was, how do I help a team balance monitoring operability work with functional work? Okay, thank you for asking that question, because I was in a talk earlier today where someone asked exactly the same question, and I really wanted to pounce on them and go like, why are you making this choice? and now I can do it from up here where I'm not in pouncing distance. And I can actually give the answer that I wanted to give, because that question made me quite a little bit sad. So I'm not sad now, though, so it's fine. So don't worry, I'm fine. So really, there's a thing here that's quite subtle, and it's about, in continuous delivery, it's called stop the line, and it's that idea from lean of, if there's a problem on the production line, we pull the and-on cord, we stop everything, we fix the problem before we continue. Yeah, the way I kind of think about it is operability, operational requirements, they're the things that make sure that your functional requirements will work as expected. I know that's a very trite thing to say. When we talk about doing one thing at a time, that's absolutely the right thing to do. Do one operational requirement, then one functional requirement. Try to maybe unpick dependencies between them. If there's some way that you're attaching value to those functional requirements, attach a value to the operational ones as well. You could do a couple of different things. You could allocate some specific time each week to work on operability stuff and say, right, 10% of our time has to be spent on operability. In XP, there used to be the idea of a gold card that I think once an iteration team could say, we're going to do some operability work this week, Mr. or Mrs. Product Owner. Also, you can say that the acceptance criteria of every feature or every story should include some operational stuff. As in, a feature can't be signed up without meeting some pre-agreed standard. Okay, so gold card, operational requirements within a story or dedicated time are 3 different ways I've seen that done. But I just think this functionality versus operability thing, it's a bit of a false conflict. It's a bit like saying, and you're not saying this, I'm saying this. It's a bit like saying, we have to choose between speed and stability. When we know from the stage of DevOps reports, we know from Accelerate, and we know from Dr. Forsgren's research that you can have it all. You can have stability and throughput. It's not a zero-sum game. But it is hard to kind of get people used to that. When a build fails on your team, do developers stop what they're doing and fix the build, or do they carry on working on new features? Builds don't fail very often. But when they do, okay, good. So that's the first step, right? I worry when I see a team where when the build fails, they all carry on. Just like, more features, more features, more features. I don't know why it's a typewriter, more features. Weird. Because that whole idea of stop what you're doing and fix the build, that's the very, very, very first step for developers towards operability, I think, okay? When you prioritize a stable build over more features, that's the first step to prioritizing a running, healthy service in production over more features, more features, more features. Okay? So thank you for the question, especially for repeating the question earlier that saddened me. That was really helpful. I didn't have to have a sock puppet ask the question, which was great. Anyone else? No? Okay, well, thank you for coming. I know it's the end of the week. Enjoy tonight. Please stay in Cornwall. Please spend your money. We need it. I don't know why people... No, don't clap that. Don't clap decades of Tory underinvestment in my country. Why would you clap at that? Ugh. Anyway, thanks for coming.